Ừm. Ừm, ừm, ừm. 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 Yes, hello, good afternoon, everyone. Could you please confirm once that you can see me, you can hear me, as well as you can see the slides? Okay, thank you. So, very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session for the course Problem Solving Through Programming in C. This course is taught by Professor Anupam Basu from IIT Kharagpur. And what we'll be doing, we'll be solving some of the questions based on the previous week's content. Okay, I'll be posting some of the objective type questions in front of you, and what you have to do, you just have to try to answer these particular questions using the chat box. Okay, so the very first question for the present session is this one. The bisection method is used to find the derivative of a function at a given point, numerical integration of a function within a range, the root of the function, or is it none of the above? Try to answer. See, good, very good. Root of the function, very nice. Do try to answer this particular question. The bisection method is used to find derivative of a function, numerical integration of a function within a range, the root of the function, or none of the above. Try to answer. This is based on uh, purely based on mathematics, but this particular concept as well as the other concepts are dealt in computer science. Okay, because basic functionalities first you have to understand, then you will be proceeding towards the high end applications of this particular field. Okay, Yes, do try to answer. Bisection method is used to find any idea. Other people who have joined, try to give your opinions regarding this particular question. Bisection method is used to find. Yes, indeed, you are correct. Okay. The bisection method is used to find the root of the function. You are correct. Okay. Let us look at the explanation. Correct answer is C. Bisection method is a numerical method. Numerical method. What is a numerical method? Numerical method means it's a particular kind of algorithm or a method that is truly fully defined. Okay. There is a starting point, there is an end point. A lot of numerical methods are there for in mathematics, and a separate course is also there, which is in the same name, numerical methods. If you are from electronics and communication engineering, you will be getting that particular course in your, I think, third or fourth semester. Okay. So numerical means method in simple terms means a mathematical procedure that has been fully defined from the starting to the end, and that is used to perform some algebraic or mathematical operation. Okay, which will not exactly provide the solution or to your mathematical problem, but it will provide you an estimation. That is the general idea about numerical method. Okay, lot of numerical methods are there for calculating the area under curve. You will be getting taught the trapezoidal rule, the Simpson's rule. These all are the mathematical rules, mathematical methods. As well as in this particular case, another mathematical method is bisection method. A particular course is there under this name only, which is your numerical methods. If you are from electronics and communication engineering, or maybe in computer science engineering also, some of the institutions offer this particular course under the name of numerical method. Okay, in either your third or your fourth semester. Okay, in this particular course you would be taught Newton-Raphson's method, and all these methods are there. Okay, they have been particularly devised in order to perform some of the mathematical manipulations, some of the mathematical operations. And the point which you have to just remember is that they are fully defined methods. Okay, so converting them into full scale programming codes is very easy. Okay, that is the particular characteristic. So bisection method is a numerical method which is used to find the root or zero of a continuous function. Prior condition is this, that the function should be continuous. It should be well defined within the domain. Okay, within a given interval. It works by repeatedly narrowing down the interval where the root lies. Okay, it would be working on directly on the principle, narrowing down the interval where the root lies. Let us look at the entire procedure. What is bisection method that has been given here? Okay, it's a numerical technique used to find the root within a given interval, that is closed interval a and b. A and b are both inclusive. Okay, where the function sign changes. Okay, that is fa and fb. The value of the function at a and value of the function at b should have opposite sign. That is the meaning. Okay, it's a bracketing method. It will start with a large interval which will contain the root, and then it will repeatedly reduce the interval size. Okay, to narrow down the root. Okay, so it will try to continuously narrow down the domain within which the root lies. Okay, that is the particular characteristic of your bisection method. Okay, how you will perform the bisection method, this is very important. In present session only we'll be looking some of the examples also. Okay, How the bisection method works? It chooses an interval, first of all, which is closed interval a and b, such that f of a multiplied by f of b is less than 0. Means within this particular a and b, there must exist a root. Okay. Why this holds? I'll just quickly go through it. Okay. If the nature of f of x is something like this. Okay. And this is two different points a and b. So now you try to see f of a is somewhat positive and f of b is somewhat negative. So when you will multiply f of a, the value of the function at a and the value of the function at b, you would be getting plus multiplied by some negative term, which will be negative term only. That is why it is written here f of a into f of b should be less than 0. That is how there would be one particular root at least should exist between a and b. Here in this particular case also, you can see that at this particular point, try to see here, this particular point, the value of the function, which is f of x, is 0. Okay, this is the meaning here. If f of a into f of b is less than 0, then there must exist a root essentially between a and b. This is the general idea. Okay. What you will do, you will just try to compute the midpoint, that is c equal to a into a plus b divided by 2. This is how you compute the midpoint. Okay. After that, you just try to see, check whether f of c is 0. Then you have got the exact root. Okay, so yes, you have hit a jackpot. Okay, finally you have found the root, but not necessarily it would be there. So now you have to either proceed towards a or proceed towards b. Okay, so how will I decide this particular thing, that I have to either proceed towards a or b? If f of c and f of a are having the opposite signs, then you try to search the root between the interval b and c by setting b equal to c. If f of c and f of b have opposite signs, then you try to find out the root, okay, by setting a equal to c. This is the general idea. Okay. Just proceed towards that particular number which would be having the value as the signs as opposite. Okay. Initially, we are finding the roots between a and b. Then we are narrowing down between the midpoint, which is c. C is a plus b divided by 2, till the number in which we will be having just the opposite sign. You have to calculate f of a, f of b, f of c. Then you have to proceed towards those two particular numbers which would be having opposite sign as compared to f of c. That is what it is written here. Okay. Repeat the process until the interval is sufficiently small. Desired precision is reached. Okay, this is the thing. So yes, analyzing all the options, derivative of a function at a given point, no. The derivative is not computed by using the bisection method. Okay. Numerical integration, no, it is not correct. Root of the function is absolutely correct. The final answer is root of the function only. Okay. One example, I'll just illustrate you through. Okay, be very careful. Keep your eyes and ears open. Just try to listen. If you want, you can note down also with me. Okay, just be with me. Okay. For example, there is f of x, which is x cube minus 4x minus 9. Now you have to compute the root of this particular function, and a range of a and b will be initially provided to you in the question. Okay. We need to find out 2 points a and b such that f of a and f of b have opposite signs. Okay. Either it would be 100% given, but if it is a subjective type question, might be there, he would not be giving you. So don't panic in this particular situation. Try with 0, -1, -2, -3, +1, +2, +3. These are the only possibilities. Okay. because he has not provided the exact range, so he would not be asking you to compute the f of x within entire 0 to 10 values, okay, or 0 to 1000 values. No, just don't panic. Calculate f of 0, 1, 2, 3, and -1, -2, -3. Within this particular range interval only, you will be getting the desired precision. Okay. So here in this particular case, I have calculated f of 2, which is -9. F of 3, I have calculated, which is 6. So there must exist between 2 and 3, since the signs are exactly opposite. So there must exist a root between 2 and 3. Okay. Now you try to see applying the bisection method. Calculating C equal to A plus B divided by 2. A is 2, B is 3. 3 plus 2 divided by 2, 5 by 2 is 2.5. Now you try to evaluate f of C. F of C is f of 2.5, which is coming out to be minus 3.375. It is negative. Okay. Now, since it is negative, we are looking for the opposite sign. Opposite sign, which would be there. Either we will proceed towards the range A to C or B, C to B. So how will we decide? We will decide on the basis of opposite sign. Okay, that is the thing. So f of 2 is negative. Okay, and f of 3 is positive. So f of 2.5 is negative. So we have to just look for the opposite sign. That is why we will be looking for another root between 2.5 to 3, because f of 3 is positive. Okay, when the symbol is changing, then only f of x will be cutting the x-axis. Okay, at that particular point only f of x will be 0. Okay, so searching the root between 2 and 2.5 will not help us. Searching the root between 2.5 to 3 will help us. It is the general idea. Okay, so now you try to see in the next iteration. I am just proceeding towards c equal to 2.5 plus 3 divided by 2. Okay, that is 2.75. Now f of 2.75 is coming out as 0.79. Okay, so one precision would be already declared in the question, that it's the root should be less than 0.5 or something like that. Okay, so till then, that particular point of time, we have to repeat this entire procedure. Okay, f of 2.75 is positive, f of 3 is also positive. So now you have to look between 2.5 and 2.75. Okay, because 2.5 is negative and 2.75 is coming positive, so there must exist a root between 2.5 and 2.75. That is the general idea. In the next iteration, 2.5 plus 2.75 divided by 2, that is 2.625. Then try to see, it is coming minus 1.41211. So similarly, you will just repeat the entire procedure. After 2 or 3 iterations, you will generally say that, sir, this is the root. Okay, this is the root. So I'll just declare that till the closest approach, till the closest decimal places, the root is approximately 2.7. Okay, but if you will continue the procedure using the programming, okay, you can achieve the desired precision up to 0.001 also. Okay, you can write a code. You have understood the procedure, then you can convert it into code, then you can provide the precision. I'll just walk you through. Okay, giving you the general idea. Then you can continue it towards till 1000 iterations also, because computer won't be having any problem in performing the computations. But when it comes to solving it using by hand, then limit yourself to 2 or 3 iterations. Either the question is subjective or objective. Okay, in the objective question, obviously the options would be given, everything would be provided, but in subjective also, I've given you the general idea. Okay, this is the particular code. I have written the code for this bisection method. Okay, for this example only. First of all, see the main function. In the main function, I have provided the initial interval, which is 2 and 3, provided the tolerance as 0.00001. Okay, then I am calling the function bisection a, b, and tolerance. All the parameters I am passing as a all the values I am passing as a parameter. Okay, then try to see this particular function, double function, which is double x. Okay, this is the function. Here I have founded the function. Okay, return x into x into x minus 4x minus 9. Okay, you also can use POW function, no problem. Then you try to see the bisection method function, which is this particular one. And it is saying if f of a or function of a into function of b is greater than equal to 0, then you have to return an invalid interval. Function values at a and b must have opposite sign. Okay, this we have to keep in mind. Then I have declared double C, then iteration equal to 1. Initially, I have written. Okay. Then I have written here printf iteration A, B, C, f of C, all values I have printed. Then I have applied the main loop or the main logic. While b minus a is greater than equal to tolerance, I have calculated the midpoint, that is c equal to a plus b divided by 2. Then I have printed all the values. If f of c, function of c equal to 0, 0.0, exact match is there, I will exit from the root. Else, if f of c into f of a, that was the condition which I was telling you. Okay, less than 0, then b equal to c, I'll proceed towards the right hand side, else I'll proceed towards the left hand side. This is how I have written the entire code. Very simple for you to understand. Okay, entire code has been written here, and I have tried to execute this particular code also. See, the results are coming in this particular form and manner. Iteration is coming, a, b, c, all values are coming, and f of c is coming. And after the 14 iterations, I have printed the value that till the desired precision, which is 0.0001. I have found out the root, which is 2.70648. Okay. No exact value. If you want to have till 16 decimal places, you would be able to calculate this also. Okay. This is the general idea. Yes, this is the summary of the entire procedure. Okay, entire thing, whatever is there in white, this is the entire summary of the entire things which I have spoken till yet. Okay, bisection method is a root finding algorithm, works on by repeatedly dividing an interval in half, selecting a subinterval in which root must lie, and the entire core idea. What are the advantages? It has a guaranteed convergence. It is simple. Disadvantages are slow convergence. Whatever is the advantage, we are just uh, that is the disadvantage also, because convergence in other of the numerical methods, okay, that happens very fast. For example, Newton-Raphson method is there, okay, but in this particular case, it will be slow convergence. Think about the function which would be somewhat to the values x raised to power 10 or x raised to power 100, and 1000 different terms are there, and then you try to repeat the entire procedure till say to 1 lakh iterations, then have a complexity in your mind. So this particular method won't be applicable in those particular advanced cases. Okay, that is the slow convergence is the primary disadvantage. Okay, yes, it requires bracket. Always it requires us to provide an interval in which the f of x should definitely have one root. Okay, so this is the particular disadvantage. Okay, so this is the entire summary. Let us proceed forward towards the next question. What is the output of the following program? And the entire code has been given to you. Options are 40, 30, compilation error and runtime error. Try to solve. B, very good. Yes, other people should also answer. Try to answer. A lot of students have joined. Yes, try to solve. Take 2 minutes time. Think. After thinking, try to give your opinion. Okay. At least give your opinions. Thereby you will remember that whether what mistake you committed, or if it is correct, then also your memory will be boosted. At least try to give your opinions. Okay. Don't feel shy. I never penalize anyone for giving the wrong answer. You must have seen in the past 10 sessions. Yes, do try to answer. It's not that difficult to answer. Try to answer. Okay. B only. No different opinions this time. For the very first time in these 10 sessions, I am having a clear majority. I'm very happy. Yes. Finally, something good is happening. Okay. Yes. You all are correct. It is indeed 30. Okay. Very simple. No overthinking in this type of questions. In this type of questions. Okay. These are bonus questions. Very easy to answer. int main is written. Int y equal to 30 is written. Then function of y function is being called. Okay. So y as a parameter will be passed inside the function. This is an example of call by value. Okay. Not call by reference. Okay. So function y is getting passed. So initially y will be passed as 30. So x will be receiving that particular value. So x will become 30. No problem. In the next line only, it is written x equal to 40. Okay. So value is changed, but the value is not getting returned anywhere. That is why when you will be printing this particular y, it will be still printing 30 because that particular change is confined to the function which is func. Okay. This is the explanation. Okay. See here, I have executed this particular code. Indeed, I am getting 30. Okay. Two particular things are there. This is an example of pass by value. Okay. So funcy or function y, the value of y, which is 30, is copied into x. Any changes made to x inside function does not affect y in the main. Okay. So modification in func will be confined to that particular function only. Final output is 30 only. Okay. This is the thing. Now you try to see here. That was very easy to understand. Here I have made some twist which I have made it is this int main int y equal to 30, and this is an example of function. After that func ampersand operator I have used, and after that I have written y. Okay, this is an example of call by reference. And now you try to see in the function void func int star x is written. This is example of function using pointer to modify the original value. This in the entire 10 in the entire week 10, the concept of pointer was dealt. So I created this particular example to make you understand the concept of pointer. Okay. So when you will be passing the address of y, okay, and there by pointer x will be receiving that particular value, and after that inside the function it is written pointer x equal to 40, modifying the value of modifying value at address x points to. Okay, so here now you have passed the cell address. Earlier also I have explained you cell address. Okay, of func ampersand y means you have passed the cell value. Okay, and there int star x, so star x is receiving that particular value. Okay, so now the original copy of the variable y is passed to func. Okay, this is the standard procedure how you can pass a value by address to a function. Okay. So now when you will be doing this particular operation star x or pointer x equal to 40, so the value of x will be entirely changed. Okay. Value of x will be changed. So value of x is pointing towards the original address of y. So y will also be automatically changed. Okay. This is the thing here. Okay. Then after that, in the main function printf %d y is written. So y will be automatically modified. Okay. So here the output is not 30, it is 40. Okay. So this particular example, you just try to keep in mind that whether it is a call by value, which was there in previous case, or it is a call by reference, whatever are these standard syntaxes, I have already explained you. Okay. This is the thing. This is the pointer version, pass by reference. Okay. Pass by address, call by address. Okay. Instead of passing y, we pass ampersand y, which is the address of y. Function now takes int pointer x, pointer to an integer. When dereferencing the pointer, this is an example, star x equal to 40, it changes the actual value at the memory address of y. Okay, so no temporary copies are created here. Here the actual value is directly modified or the address is passed. So final output will be 40. Okay, so printf %d y will print 40. Okay, this is the thing. Correct answer is 30. Analyzing this particular C code, understanding pass by value. This was there in this particular case. Other case was passed by reference or call by reference. Okay. The function arguments are passed by value by default. This means funcy is called. A copy of the value of y is passed to the func function. Okay. Changes made to the parameter x inside the func does not affect the original y, but in the next case which I dealt, okay, which I created, the value of y exactly is getting changed. Okay, this is the thing. Step by step execution and everything is there. Okay, if at any point of time any student is having any doubt, okay, please unmute yourself. You can just ask directly. Okay, don't feel shy, don't hesitate. Okay, or use the chat box, which whatever feels better to you. Okay, I have to explain a lot of things in 2 hours of time. That is why after every question it is my habit to just ask whether you have any doubt or not. So I'm not asking. If at any point of time any student is having any doubt, please unmute yourself, ask the doubt. Okay, or you can use the chat box. Okay, so proceeding forward. Okay, try to solve this next question. What is the advantage of a recursive approach over an iterative approach? Okay, try to answer. Consumes less memory, less code, and easy to implement, consumes more memory, more code has to be written. Okay, try to answer. Both the things you know. Recursive approach means calling function inside a function. Okay, again and again you have to call. Iterative approach means directly applying the loops. Okay, iterative. One iteration, two iteration, second iteration. For example, for loop, while loop, do while loop. Okay, these are the examples. Try to answer. B. Okay, good. Less code and easy to implement. Very good. Yes. Okay. Why only one answer? Please try to answer it. Okay, it's an easy question. Try to answer, give your opinions. Okay, three people have answered B. Good, very good. Any more opinions? Anybody? Okay, good. B. Arunima is saying B, then Aman is saying B, Rakshita B, S. Sharmitha B. Okay. Yes, indeed, you are correct. Okay. The particular advantage of a recursive approach over an iterative approach is this only: less code and easy to implement. Okay, this is the thing. Recursive approach has the advantage of less code, often easier to implement as compared to an iterative approach. Advantages include less code, more readability. Readability, what is meant by readability? Recursive solutions are often shorter, more intuitive. Okay, they are more governed by the intuition. Okay, whatever you are thinking, you are able to implement. That is the thing. And readability means the entire length or the bulk of the code is decreases. So if you are writing the code in short, it will further enhance the understanding. That is the meaning of readability. Rather than their iterative counterparts, sometimes iteration becomes too much lengthy. Okay, iterative approaches. Example, we'll just see calculating factorial using recursion or either by using the iteration. Okay, easier to implement for tree and graph problems. Function inside a function you will be calling. Okay, recursive functions are naturally suited for problems like the your tree traversal in order, pre-order, post-order, or anything like that. Traversing a binary tree is easier using the recursion rather than the loops. Okay, solving proofs problems that have overlapping subproblems. Recursion is useful for problems following the divide and conquer approach we have dealt, okay, in the previous lecture only. For example, in case of your merge sort, quick sort, Fibonacci series, we have just seen. Okay, so recursion helps us there. Okay, this is the thing. Disadvantages of recursion: it consumes more memory. Okay, because of the entire full end stack usage, I already have told you. Okay, the multiple copies have to be created of a single function. Sometimes it leads to complexity overshoot problem. Okay, each function call creates a new stack frame in the memory. Too much recursive calls can lead to stack overflow. We just have seen in the previous lecture only. Okay, Fibonacci series using recursion is having the complexity big O notation 2 power n complexity, making it inefficient. Okay, it is having slower execution. Function calls add extra overhead due to pushing or popping from the call stack. Okay, this is the thing. Try to see this particular example using the recursive approach. If we will try to compute the factorial of a number, the code would be something like that: hash include stdio.h, then int factorial, int n. If n equal to 0, then return 1. This is the base case because factorial of 0 is 1. Then you have to return n multiplied by factorial n minus 1. Okay, so directly the values will get multiplied. At the end, you will just get the output. And in the main function, you have just called the function, okay, using that particular integer value, and then you have returned 0. Okay, this is the thing. So you will get the output of factorial of 5 is 120. This is the output which you will get. Okay, this is the thing. Using the recursive approach. Now, using the iterative approach, also you can just make this particular function of calculating the factorial of a number very easy. Hash include stdio.h, int factorial, int n is there, result equal to 1. For int I equal to 1, I less than equal to n, I plus plus result multiply equal to I, okay, or result equal to result into I. Directly you can apply a for loop and use the iterative approach. Then meanwhile you can return the result, and inside the main function you just have to call this particular function with the variable or the value which is 5. Okay, so both the approaches are there, but both the approaches have their advantages as well as the disadvantages. Okay, depends on our use case. Okay, in which particular case we want to use which particular approach. Okay, this is the thing. Conclusion is this, that recursion makes code simpler, readable. It is easier for tree traversal, sorting, divide and conquer type of techniques or approaches. Iteration is more memory efficient. Okay, usually it is faster. Okay, so these are the advantages. In whichever cases you want to use, you can just use. Okay, so correct answer is less code and easy to implement. Okay, final answer like this. Yes. And the entire explanation here explicitly have been explained in very simple terms. I have written it. Okay, correct code is less. Correct answer is less code, easy to implement. Expression goes on like recursive solutions. They are computationally, conceptually similar, simpler, require less code to explain certain the algorithms. Okay, just single line was there, but in the iterative approach you have seen four lines are there. Okay, this is the thing, and iterative solutions are memory efficient, generally they are faster. This is the thing. Final idea like this, that using the recursive approach will improve the readability and provide us a simpler code. This is the thing. Okay, moving forward, which of the following is not an application of binary search? Okay, and binary search entire idea I provided you in the previous lecture. Try to solve. Options are to find the lower or upper bound in an ordered sequence, union of intervals, yes, debugging, or to search an unordered list. Okay, try to solve. D, very good. Very good. D. Yes. Other opinions? Anybody? D. Very good. D. Good, good. Okay. Five particular opinions are in favor of D. Anindita Paul and Arunima Paul, they are both very regular. Arunima is still answering, but I don't know about Anindita. She is very regular, but nowadays she is not answering. Anindita, if at any point of time you are having any doubt, then please unmute yourself as you used to do in the previous, in the initial sessions. Okay. If at any point of time, if any person is having any doubt, please unmute yourself, ask the doubt, clarify it. Okay. Try to be somewhat participative. Okay. So the meaning of the session as well as the fruitfulness of the session will increase. Okay. This is the thing. As well as other students are there. Cyan is also very regular. Steven is regular. Sharmita regular. Priyanka is also very regular. Krish, yeah, good students are regular, but please try to participate. Okay, your confidence in the examination will only increase if you will participate. Okay, mine era of giving the examination has ended. Okay, so now it boils down to you. You are the students. You have to answer the questions in the examination. So your confidence will only get boosted when you will just participate in the sessions. Okay, this is the thing. Yes, the correct option is D only, to search an unordered list. Okay, to search an unordered list, these all the applications to find the lower upper bound in an ordered sequence, union of intervals, as well as debugging are the applications of binary search. But prior condition in binary search, I already have explained you, was that the list has to be ordered. So directly you can eliminate this. D would be the correct option because it is asking not an application. It is not asking an application. It is asking not an application. Okay. So that is why the correct option would be D only. Okay. This is the thing. Binary search only works on sorted arrays, ordered sequences, does not work on unordered list because of the fundamental assumption of binary searches that the data is sorted, analyzing each and every option to find the lower or upper bound in an ordered sequence. Yes, it is a correct application. Binary search is commonly used to find the lower bounds or the upper bounds in a sorted list. Okay. Union of intervals. Yes, it is a correct application. Binary search is useful in interval merging, event scheduling, range searching. Yes. Debugging. Yes, it is used for debugging, for finding the smallest test case in which is causing a bug. Okay. These are the few applications. Okay. To search an unordered list, no, it will not be an application because primary condition is that the data should be sorted. Okay. If the list is unsorted, binary search won't be working. Okay. We should use linear search in that particular case because it will work for both the ordered and unordered list. Okay. Just a second. What happened? Yes. Yeah. For example, here in this particular case, if you will see this particular test case, this is the entire code of your binary search. Okay. This code as well as the application I have specifically supplied in week number 9. Week number 9 is the most comprehensive as well as the most difficult or the tricky concept. A lot of concepts are there in week number 9. So before the examination, if you are having some short time or if you are not able to revise the entire thing, okay, just focus on week number 9. Week number 9, at least you should revise multiple times because it is containing a lot of the concepts. Okay, this is the thing. So in that particular week number 9 or the previous session only, this particular code was there, hash include stereo.h, then standard binary search function, which is there. Either you are moving in left direction or you are moving in the right direction. You are always calculating the mid and then you are comparing the key. Okay, either you have to move left or right. Specifically, I have covered in the previous week or week number 9. Here I am just supplying an array which is 10, 5, 8, 20, 15. Okay, this is an unsorted array. And when I am giving the key is that particular element that has to be found out. Okay, I am supplying the key as 15. Then you try to see 15 is already there in the array. But since it is an unsorted array, the code is returning element not found. Okay, why is it happening so? Because you are not supplying it with a sorted array, because the entire idea of binary search will only work when it is a sorted array. Okay, this is the thing. Binary search is a powerful algorithm used for searching the sorted data efficiently. It will not work on unordered list because the middle element does not provide useful information for further searching. For unordered list, use linear search instead. This is the thing. Okay. See here, this entire thing. Okay. Hash include stdio.h is there, then entire code is there. That particular code only which I just showed you, that I have tried to execute in the compiler. Indeed, here when I am providing an unsorted array, it is returning element not found, even though the key or the element which I was searching was 15. So still the thing is there, that element not found I am getting. Okay. But when I am just supplying it with a sorted array. Here unsorted array won't be there. It would be a sorted array. Okay. It would be a sorted array. Okay. Sorted array. This one is sorted. This one is a sorted array. Okay. Yeah. This one is a sorted array. When I am supplying it with a sorted array, then I am getting the result as element found at index 3, or it is found at the fourth place. Okay. Here you can see index 0th index element would be 5, then 1 would be 8, 2 would be 10, 3 would be 15. So index 3, at index 3 I found out the element 15. Okay. Or it is found at the fourth place if you are counting from 1. Okay. Same code, just providing the sorted array instead of unsorted array. Same code, everything is same. Okay. This is the thing here. Application I've just demonstrated in front of you. Okay. This is the thing. Correct answer is indeed D. Okay. The correct answer is D, to search an unordered list. Okay. Because binary search requires data to be sorted in order in order to work it correctly. Okay. Then unordered data, no. In case of unordered data, binary search is useless. You have to go for linear search. Analyzing the options, finding the lower or upper bound in an ordered sequence. Binary search is often used to find the lower or upper bound of a range in a sorted list, particularly if you need very efficient search. Union of intervals, not a direct application of binary search. It is used to perform operations that involve intervals. Okay. Just combining intervals into a union or for debugging. But D, or to search an unordered list, won't be the application, hence it would be correct because it was asking not an application. Okay. Moving forward. Okay. For a continuous real function or a real continuous function, if f of x, f of a into f of b is greater than 0, then in the range which is closed interval a and b, for f of x equal to 0, there is exactly no one root, no root, one at least one root, or roots are undermined. Okay. Try to give your opinions. Try to think. Lot of students have joined. All should try to answer. Okay. Try to answer. Take your time. I'm just coming in 2 minutes. Okay. Yes. Okay. Majority people are saying B. No root exists. Okay, good. Cyan is saying exactly one root. Okay, good. Okay, good. So Cyan, please see that it is written f of a into f of b is greater than 0. When two quantities are getting multiplied, when they are greater than 0, either it is plus plus or minus minus. Okay. If the opposite symbol is there, then it would be less than 0. Okay. And I told you that in case of intermediate value theorem, f of a into f of b is less than 0, then there exists one root or multiple roots, at least one root exists between the closed interval a and b. Okay, so it is written greater than 0. I think you misunderstood by less than 0. That is why you have committed a mistake. It is indeed no root exists. The correct option would be no root exists. Okay, because f of a into f of b is greater than 0, then the nature of the function would be either increasing, decreasing in the closed interval a and b. Okay, if this is a, this is b, for this f of a into f of b greater than 0, then the function should be either here or it should be here. If the case is somewhat like this, then only f of a into f of b is less than 0. Then in that particular case, this particular root you can see here, this is existing in the closed interval a and b. Okay. In these both the cases, you can see f of a into f of b is greater than 0. F of a into f of b is greater than 0 because both the values are negative. So negative negative is positive, negative negative is positive in case number 1 and 2. Case number 1 and case number 2. But in case 3, you can see f of a into f of b is less than 0, hence there exists a root between the closed interval a and b. Okay, no root exists. It would be the correct option if f of a into f of b is greater than 0. Okay, this is based on intermediate value theorem, which is a fundamental numerical method just like the bisection method. Okay, another name we have given, or just from the bisection method, this is a corollary. Okay, this is the thing. The theorem states that if the function x is continuous in a closed interval a and b, and if f of a into f of and f of b have opposite signs, that is they are less than 0, then there exists at least one root between uh, a and b, closed interval a and b. That is the thing, such that f of c is 0 if c is the root. In this particular question, we are given f of a into f of b is greater than 0, which means both fa and fb must have the same sign. That is, either they are positive or they are negative. This means there is no guarantee. As I have already showed you with the graph, okay, no guarantee is there such that f of x crosses the x-axis in the interval. Hence, there is just no root between the closed interval a and b. This is the thing. If fa and fb have opposite signs, the function must cross the x-axis, root exists. Fa and fb are having the same sign, then no root exists. This is the concept. Okay, with an example also we can see f of a is -3, f of b is 5. Then the function must cross the x-axis, at least one root exists. If f of a into f of b is greater than 0, then both values are either positive, both values are either negative. No root exists between closed interval a and b. Okay, this is the correct answer. Explanation in short. Okay, IVT theorem very crucial here, and whatever the things I have said is written here. Okay. moving forward, I hope that it is clear to all of you. Okay. Assuming an initial range closed interval 1 to 5, second iterative value. Okay. Second iterative value is the end of the two iterations. The second iterative value of the root t e raised to power minus t minus zero point 0.3 using the bisection method is only the second iterative value of the root you have to calculate, not the function. Okay. Take a copy and pen, try to solve. Okay, these are the very common questions in the examination. One particular problem in this session only, as the problem number 1 I have already explained you. Same method we will use, everything same we will use. Take 2-3 minutes time, 5 minutes time, try to solve this particular question. Okay, here itself only, then I'll explain you how I have performed it. Okay. Even if you know the answer or you have solved the previous assignments also, or same question is there in the assignment, still take a copy and pen, give your 5 minute time, try to solve it. Okay. Yes. Okay. Two. Very good. Three people have solved. Very nice. Rest also try to solve. I'll be giving you 1 more minute, then I'll be explaining you what is the correct option, how did we achieve it. Very good. Even if you know the answer, okay, still you should try to solve. Okay, take a copy, pen and paper, try to solve. Okay, it is nothing. Two midpoints you just have to calculate. Okay, so very easily you will be able to achieve the iterative value of the root at the second iteration, second iterative value. Okay. Try to solve. Okay. After two iteration, the iteration value of root is 2. Good. Very good. In total, 5 people have given their opinion in favor of option number B, which is 2. Yes. Indeed, you are correct. It is 2 only. I'll provide you the step-by-step procedure. Finding the second iterative value of the root t e raised to power minus t minus 0.3 using the bisection method. Let us solve it step by step, recalling the bisection method. First of all, bisection method works by repeatedly halving the interval, closed interval a to b, where the root lies based on the sign at the function of the function at the endpoints. Iterative formula is t mid, which is a plus b divided by 2. At each iteration, calculate f of t mid, or the value of t. F of t you have to calculate. Depending on the value of f of t, if f of t into f of a is less than 0, then root lies in a to t mid. Okay. Or if f of t into f of b is less than 0, then the root lies between t mid to b. Okay. This is very important. In the previous question, in the previous explanation of question number 1, you either would be having some of the confusion. Then keep this in mind. This is very easy to understand. Okay. How to proceed, in which direction I have to proceed. Either I have to proceed in the right half or the left half, that you can decide using this particular very easy manner. Okay. This is the thing. We have been given the function which is f of t is t e raised to power minus t minus 0.3. Okay. Initial range is 1 to 5. Calculating f of a, f of b. Okay. F of 1 is 1 into e raised to power minus 1 minus 0.3, which is 0.3679 minus 0.3, which is 0.0679. Okay. Always remember e is having the value of 2.71. Okay. So if you are not in a position, or if you are having only few minutes time at the end of the examination, then directly put 2.7 here. Okay. Don't use the calculator or physical calculator or the virtual calculator. You don't require anything. Then just try to calculate it manually. Okay. Try to approximate the values, so you would be able to achieve the correct option. This is very important for you to understand in the gate examination. Okay. If you will be writing the gate examination at the end of your 4th year, then you have to devise some of the quick calculations, because there the time is very limited. It is a competitive examination. For the semester examinations as well as this examination, you can put the value, calculate the exact amount of value, but in the competitive questions, directly you have to put, and then you have to just decide in which direction I have to proceed, and then tick on the correct option, and then proceed toward the next question. Okay. So f of 1 is just 0.0679. Then f of 5 is 5 into e raised to power minus 5 minus 0.3. Okay, that is coming to negative minus 0.2665. Okay. Yes. Since f of 1 is greater than 0 and f of 5 is less than 0, so there must exist a root between closed interval 1 to 5. Now calculating the midpoint. Midpoint is t mid, which is 1 plus 5 divided by 2. Okay. Which is equal to 3. Midpoint is 3. F of t mid is 3 into e raised to power minus 3 minus 0.3, that is minus 0.1506. So f of 3 is negative, and which of the values is negative? Okay, f of 5. Okay, I'll repeat at the end. Let me just finish, then I'll repeat the entire thing once. Okay. So t mid I have calculated, which is 1 plus 5 divided by 2, which is equal to 3. Okay. F of t mid is f of 3, because mid value which I am getting is 3. So 3 into e raised to power minus 3 minus 0.3, because t into e raised to power minus t minus 0.3, which is coming out to be minus 0.1506. So which of the values among f of 1 and f of 5 is positive, because I have to look for the opposite sign. Okay. So since f of 3 is less than 0, so there lies a root between 1 to 3. How did I achieve it? I already told you, look for the opposite sign. Okay. Between t mid and a and b. Okay. 3 values, look for the opposite sign. So since it is negative, so I will look for the positive value. Okay, positive value. I am between f of 1, which is a, f of a, f of b, which is f of 5, f of t mid, which is f of 3. So looking towards the positive value is 1. Okay, f of 1, which is 0.0679. So there must exist a root between f of 1 and f of t mid, which is 3, which is coming out to be minus 0.1506. So I'll proceed towards 1, 2, 3, closed interval 1 to 3. So updating the interval a comma b to 1 comma 3. Okay, this is the thing. In the second iteration, I'll again calculate the t mid, which is 1 plus 3 divided by 2, which is coming out to be 2. This is the correct option. Okay, this is the correct option. T mid is 2. Okay, this is how you get the correct answer, which is 2. Now you calculate t mid if you want. F of t mid you try to calculate, which is f of 2. So 2 into e power minus 2 minus 0.3. Okay, if you will calculate this particular value, it would be minus 0.0294. Now, in which direction you have to proceed? You just have to calculate. Okay, in which direction you have to proceed? You just have to see f of 2 is coming negative and f of 1 was positive, f of 3 was negative, and f of 3 is also f of t mid, which is f of 2, is also negative. So we look for the opposite sign. So since f of 1 was positive, f of 2 is coming negative, so there must exist a root between 1 and 2. Okay, so we will, in the next iteration or iteration number 3, we will look for the root between 1 and 2. Okay, this is the thing. Updating the interval, closed interval a comma b between 1 comma 2. Okay, so within the scope of this particular question, we are being asked second iterative value of the root. So it will be calculated as t mid equal to 2. Okay, this is the thing. So this was regarding your calculating the second iterative value. Okay, so in the next iteration or the third iteration, look for calculate, use the same procedure, calculate t mid. T mid will be 1 plus 2 divided by 2. 2 plus 1 divided by 2 is 1.5, 3 by 2. Okay, so calculate f of 1.5, then decide whether you will go reduce the range between 1 to 1.5 or 1.5 to 2 based on the sign value. Okay, and how I am deciding it, just going towards the positive. If f of 1.5 comes positive, I know f of 2 is negative, then I'll go for searching between 2 and 1.5. If it comes out to be negative, I know that f of 1 is positive. Okay, so I'll have to take the decision accordingly. Okay, this is the thing. Entire procedure, everything I have explained. Still, if you have any doubt, please ask me. Okay, this is the procedure, entire procedure in short, in 4 lines only. If you want to calculate tu or t mid, okay, is coming 5, then f of tu is coming negative, then another TL is 1, f of TL is 0.0679, then f of tu and TL is negative, exist one root between 1 and 5. So t mid here also I am calculating at iteration 1, that is coming out to be 3. F of t mid is less than 0. Okay, so f of t mid is less than 0, so there exists a root between 1 and 3, because opposite sign we will look, we will not go we will not look for the root between 3 and 5, because f of 3 is negative, f of 5 is also negative, we just have to look for the opposite sign. So we will look for the root between 1 and 3. Okay, so just calculating t mid, which is 1 plus 3 divided by 2, it is coming 2, hence the root after iteration number 2 is 2. Okay, this is the thing. Okay, at any point of time if you are having any doubt, then please do try to ask me. Okay, Rest we have to proceed forward. Okay, what will be the output when you will execute this particular C code? Try to answer. Concept related to pointers, and pointers is also only getting dealt in this week. Okay, try to answer. Hash include stdio.h int main, then short num is a two-dimensional array, then printf. After in printf some statement is written. Okay, try to solve. Okay, a. Three people are saying A. Good, very good. What about the others? Yes, I don't know. Some issue is there with the meet. After some point of time, I generally get logged out. I don't know. That is why I am using three devices so that I can monitor. Some issues there with Google Meet. I don't know what is that. I am still trying to figure out. After some point of time, generally after 1 or half hour, I get logged out automatically. But with my other devices, I am able to just see. Yes, take your time. Already four students have said as option number A. Good, very good. Let us look at what is option A. What does it want to say? What is the concept behind? Yes, the correct option is option A only. Okay. It is 2311 only. Okay. Correct would be this one only. Yes. Let us see why is it correct. Analyzing the given code step by step. Code wants to say to us hash include stdio.h int main is written short num which is an array declaration, two-dimensional array declaration is there, 3 comma 2. Then the elements are there, and then after printf %d %d, two values will be printed, which is pointer num plus 2. Okay, and inside that index has been provided as 0. Okay, then another value has been provided, which is two particular pointer symbols we have used, star star num plus 1 directly. Okay, first of all you have to understand the structure of the num array, which is two-dimensionally it has been declared, and num 3 comma 2, and the elements have been provided to you. It means that num 0 0 is 2, then 0 1 is 5, so 1 0 is 11, 1 1 is 17, then 2 0 is 23, then 2 1 is 28. Okay, this is the entire structure. I have plotted the array in two-dimensional also, in two-dimensional in a tabular form also. Row 0 1 2, then column 0 1. Okay, so this is the entire array in tabular form, very easy to understand. Internally the 2D array is stored in a row major order, in the entire as a row it would be stored. But the thing which you have to understand is this one, that first of all the expression pointer num plus 2, and inside that index has been 0. Okay, num is the base address of the array pointing to the first row. Okay, num plus 2 will move towards the third row. Okay, not to the second row, because indexing in C is from 0. So num plus 2 will move towards the third row, which is this one, 23 comma 28, third row, row number 3. Okay, num plus 2. Num plus 2 means 0 1 2. Okay, 2, second row. Or either you want to say in form of index, or you in form of grammatical or English language, it would be third row. But for us, it would be indexed row number 2, num plus 2. Num by default would point to 0th row. Num plus 1 would be first row. Num plus 2 would be your third row. Okay, 0th row, then first row, second row, or third row, whatever you want to call. You just try to understand the emotions behind it. Okay, num plus 2 will move towards the third row, which is 23 comma 28, 28, this particular last row. Then pointer num plus 2 will dereference, or it will point to access this particular row, which is 23 comma 28, and pointer num plus 2 and index 0 will look for the element 0, element 0, or column number 0. Okay, will access the first element of this row, which is 23. Hence pointer num plus 2, 0th element is 23. Now you try to evaluate the second expression, which is star star num plus 1. Num plus 1 will move towards the second row, or the indexed first row. Okay, which is 11 comma 17. See here in this particular table, num by default will point to the 0th row, num plus 1 will point towards the first row. Okay, this particular one, 11 comma 17, or in English language it is second row in terms of table. Okay, try to understand. Then pointer num plus 1 references this particular pointer to access this particular array, which is 11 comma 17. Then pointer star star will access the first element of this row. Star star by default will access the first element of the row, which is 11, and the combined output is 23 comma 11. Okay, this two particular syntaxes as well as what is the meaning you must understand, then only you will be able to achieve the correct option. Final print result is 23 comma 11. Okay, three cases I have just printed. Okay, so for you to understand, hash include stdio.h, and then this particular First case is given in the question. It is returning me 23,11. Then I dereferenced first element. I removed square bracket 0. I just added a pointer, and with the second element num plus 1, I added 0 in the square braces, and I removed one star. So it is indeed giving me another value, okay, which is 23,11, same value I am receiving as the output, okay. But in the third case, I did some manipulation. I dereferenced it. I didn't dereference it, neither I provided the index. So try to see here. This particular case is very interesting. Okay, for your own understanding. Okay, I cannot use the pointer here. No problem. Okay, I still use. Just 1 second. Yeah, yeah. Try to see this particular case here. I have written star num plus 2. Okay, only this much information I have written. So pointer num plus 2 will have the access of the second row, 0, 1, 2, second row, or third row in English language, or second index row. But I have not provided the absolute address of the value. If I'll just increase one pointer or one star symbol before, then it will be automatically referencing towards the first element. But here I have not provided that particular facility, so it is returning me GIGO, garbage in, garbage out. Okay, it is returning me this particular value. It is having no particular uh, value, no particular significance to us. Okay, it is returning me garbage value or the cell address of the value. Either three options would be there: garbage value, any and not a number, or anything else which is not significant to us. Okay, all three options would be correct. And the second particular element, which is star num plus 1, and I provided the index. Okay, so it will be returning me the exact 11. Okay, so for your own curiosity as well as for your understanding, I have provided you these three cases. Okay, in which case you will get which value, you have to understand. Okay, moving towards the next question. I hope that it is clear to you. Okay, I hope that nobody would be having any doubt. If any doubt is there, please unmute yourself or use the chat box to ask me. Okay, try to answer this particular question. Assume size of an integer and a pointer is 4 bytes. Okay, size of an integer is 4 bytes. Okay, and pointer is there. Then what is the output? Question should have been assume size of an integer is 4 bytes. No pointer should be there. This is creating confusion. Size of an integer or a pointer to an integer would be same only, which is 4 bytes. Then what is the output? Try to solve it. B, good. Very good. B, very nice. I think you just remember the correct option, no problem. Try to calculate also, okay? Even if you know the correct option, try to calculate. Take a copy, pen, paper, everything you calculate step by step. Write the code aside. Thereby your skills will improve, okay? Okay, yes, indeed. You all have answered it very correctly. It is 320 only. Okay, why is it so? I'll explain you in great detail. First of all, you have to understand the entire code. Hash include stdio.h. As defined, A is defined, B is defined, C is defined, then int main is written, then int pointer x, then within that it is written A, B, C, square braces it is written, so it will not raise an error because A, B, C are already defined, okay? Then printf %d, then size of pointer x. Pointer x, what is the size that we have to calculate, okay? That will be only printed. So first of all, pointer declaration will understand x is a pointer which is pointing towards a four-dimensional array with the sizes A, B, and C, meaning A is 5, B is 8, C is 2. It is not a four-dimensional, it is a three-dimensional. Okay. By mistake, I have written here. Sorry for that. It's pointing towards a three-dimensional array. Three dimension would be only there. Okay. Yes. It is pointing towards a three-dimensional array of size A, B, C, meaning A is 5, B is 8, okay, C is 2, X is a pointer to a block of a memory that stores how many integers in total? 5 into 8 into 2, which is 80. You must be understanding in tabular form, okay, which is 5 into 8 are the total number of elements, okay, multiplied by 2 in total tables. So in total, the number of integers which are stored in this particular three-dimensional array would be multiplication of the size, which is 5 into 8 into 2, that is 80. And every integer is occupying how many, what is this memory? What is the total memory? It is integer. So it will be occupying 4 bytes. Okay. Already given in the question. So 80 multiplied by size of one particular integer, that is 4. So 80 into 4 is 320. So 320 bytes is the total amount of size of pointer x. Okay. This is the total size. Printing the output, which will give me 320. Okay. This is the answer. Very easy to understand. See here, I have executed this particular block of code. Okay. Entire code I have executed. Indeed, I am getting 320. But in case number 2, I have not used the pointer. Okay. So even if I don't use the pointer, the size of x will remain the same. Okay. Everything is declared in the same manner, and I am getting the output as 320 only. Okay. The explanation goes like this: breaking the C code, seeing how size of operator is working. Entire code is there, then understanding x is declared as a pointer to a 3D array of integers. The dimensions of array are A, B, C using the defines, which is 5 into 5, 8, 2. Okay. Size of point x is a pointer. Star x is a dereference pointer, which is array of type int, integer. Okay. Size of x calculates the exact memory occupied by the 3D array, which has dimensions 5, 8, 2. Okay, the size of each integer is assumed to be 4 bytes. So total 5 into 8 into 2 are the total number of elements. Each element is occupying 4 bytes, and the entire size is 320. Okay, this is the explanation to this particular question. But there is a twist. Always there is a twist. So in this particular question only, if I declare this particular array, okay, when I am declaring, I have removed the pointer, but when I am printing, I have included the pointer. So the output which I am getting is 64. So I hope some of you will be able to get it the correct output, but most of you would be very, very confused. Okay. Because here I have removed the pointer and here I have included the pointer. So what is happening in this particular case? Why I am getting the output as 64? Not why I am not getting the output as 320? This we will see. Try to see here. Understanding the array declaration has defined A, B, C. X is declared as a 3D array of integer with dimension A, B, and C, which means A is 5, B is 8, C is 2. X is effectively defined. Okay. as int x582. This means x is an array with total elements 5 into 8 into 2, 80 integer elements. That is same. Okay. The thing which changes is in step number 2, evaluating size of pointer x. Okay. Pointer x represents the first element of 3D array. Okay. Pointer x, which is x in bracket 0. Already explained in the previous question. X comma 0 will now become a 2D array of the size 8, 2. Okay, B and C are 8 and 2. See here. Okay. So the number of elements in x0, okay. The pointer x is pointing to x0. 0 is the index. Okay, first index. Okay, A value will become 0 here. Rest of the elements are 8 and 2. Okay. So number of elements which are there in x0 or the 0th row, okay, of the array are 8 into 2, which is 16. Now size of this particular pointer x will be 16 multiplied by 4, because each int or integer value will be having 4 number of elements. Okay, 4 bytes of the memory. So size will be 16 into 4, which is 64. Okay. So that is why the array is that is why the updated code which I have made for your understanding is returning me the answer as 64. So size of pointer x references to the size x0, okay, which is 8 comma 2 array. The total number of elements in x0 is 8 into 2, which is 16. Each integer takes 4 bytes. So in total, what is the size, which is 16 into 4, that is 64. Final output is 64. That is the thing. Okay. I hope the updated code as well as the execution is clear to you. Okay. This is the thing. Sir, can you please once more how 64, what comes change in the program? Okay, I'll just show you. The thing which has changed here, okay, is this particular one only. Here I have I have declared it without pointer. You can declare it with pointer also, you will get the same result, no problem. But when I am printing size of pointer x, size of star x. Okay. So star x is automatically dereferencing to the 0th row of the three-dimensional array. So a value x, a, b, and c is there. A automatically becomes here 0. Okay, as we have seen in the previous question. So b and c are only left. So b and c is 8 and 2. Total 8 into 2 number of elements are there. 8 2 is 16, and each int value or integer value is having 4 bytes of memory. So 16 into 4 is 64. So size of pointer x will return me 64. That is the answer. Okay, that is why I am getting output as 64. Is it clear to Steven? Or still any confusion is there, then please ask me. Okay, clear. Okay, no problem. Okay, no problem. Yes. Just a second. Yes. Try to solve this particular question. Find the output of the following program, and the code has been given to you. Okay. Easy question, easy answer. No confusion. Bonus question. All should get it correct. Okay. Yeah, good. Rolly is saying B. Very good. Good. Very good. Rajesh is also saying B. Very nice. Try to evaluate. Easy question is there. 12 minus 24 is minus 12. Yes, that is the entire logic. Good. Sayan is saying B. Very nice. Yes. Very nice. Three opinions only. Good. Yes. Okay. Indeed, all three of you are correct. The correct option is minus 12 only. Okay. Executed the code, got the correct option is minus 12 only. Okay. Why is it so? See here, analyzing this code. First of all, what is written? Int star ptr, comma, a equal to 12. Okay. So pointer is declared as an integer pointer. Initially points to a garbage memory because you haven't declared it, you haven't pointed it, or you haven't set the reference value. A is declared as an integer initialized to value 12. This we understand from the first statement. Then in the second line, ptr equal to ampersand a. PTR now holds the memory address of A, means any change which is performed to PTR will be there with A also. Okay. So PTR is now pointing to A. This is second line. Now third line is star PTR equal to star PTR minus 2 into star PTR. That is how you will see it. Okay. Star PTR refers to PTR, pointer, points to A, which is A only. So star PTR into equal to star PTR minus 2 into star PTR will be A equal to A minus twice into A. That is equivalent to that only. This is not mathematically correct. A equal to A minus twice into A. I have written this for you to understand. Okay. Because the statement is there, star PTR equal to star PTR minus 2 into star PTR. So it is equal to A minus twice into A. That particular value will be computed and that will be updated inside A. That is the meaning. Okay. So A declared as 12. So 2 into 12 is 24. And A minus twice of A will be 12 minus 2 into 12. So 12 into 2 is 24. 12 minus 24 is minus 12. So A is updated as -12. Pointer, which is having the memory address of A, will also be modified, and now it will be pointing to -12. So printing both the values PTR, star PTR and A. Star PTR is the value pointed to by PTR, which is now -12. So A is also -12 and pointer is also -12. Both values will be -12 only. Hence B option will be correct. Okay. I hope that it is clear to you. If anybody is having any doubt, then please do ask me. Okay. Rest I have to move forward because within the scope of any 2 hour session, I have to explain you a lot of things. Okay. That is the thing. What is the output? Hash include stdio.h, int main, then character star s equal to programming, star p equal to s, printf, %c, star p plus 3, then s3. Okay, go with the same logic which we have seen in 8th question, 7th question. Okay, go with the same logic, and within the same logic, try to just evaluate this particular question. Okay, yeah. Here at IIT also, the classes are of 2 hours only, 2 hours or 3 hours, but within 2 hours, also we don't explain this much number of slides or this much number of concepts. Okay, so I can understand that sometimes it would be much critical to you to understand, but don't worry. Go through the PDFs, go through the recordings. Okay, if anything is not clear to you, then please revisit the concepts. Okay, I have tried to make as detailed slides as possible. Okay, that is the thing. Okay, one person is saying B, other rest are saying C. Sayan is saying B. Roly Rajesh, okay, both are saying C. Then Sayan again is saying C, no problem. But in the examination, please have a concrete concept. Don't figgle between the options. Okay, this is the thing. Actual answer is C. Okay, good. Okay, yes. Indeed, the correct option would be C only. G, comma G. Okay, that would be printed. Let us see. This is the code. Hash include stdio.h. int main is there. Character pointer s equal to programming. Okay, then pointer p equal to s. Okay, then printf %c pointer p plus 3, then s. Within that square braces it is written 3, then return 0 is written. Variable initialization character pointer s equal to programming. S is a pointer to a string which is programming. Okay, this is the meaning. Character pointer s equal to programming. S is a pointer which is pointer to a string naming the entire string is programming. Programming is only stored in read-only memory. Okay, the string programming is extended as follows: the index as well as the entire string programming. Okay, that we have just break down. This is how you should break it down in the examination also. Don't be very overconfident. Okay, that I'll just calculate something and then I'll put out to the answer. Be very sure before answering. Okay, so write down the entire array, and above that use the your pen or pencil, whatever you want to use. Write down the indexes: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how you should approach. Then character pointer s equal to s, pointer p equal to s, that is written p is assigned the same value as s, so it points to the beginning of the string which is programming. Character pointer p equal to s. Okay, this is the meaning. Now I want to print two particular values, which is pointer p plus 3 and s3. So printf statement, if I will try to evaluate pointer p plus 3, p points to the beginning of the string, p plus 3 moves the pointer 3 positions forward. That is the meaning here. Pointer p plus 3. P plus 3 will move the pointer 3 positions forward, pointing to the index 3, which is G. See here, index 3 is G. Here it is written, okay? Index 3. What happened? Yeah. Index 3 is written here as G. Okay. This is the thing here. So p plus 3 moves the pointer 3 positions forward, pointing to the character at index 3, which is G. So star p plus 3 re-references this pointer and retrieves the value G. S3 will again directly access the character which is indexed at 3, and in the string programming it is G. So final output is star p plus 3 and s3 both will point to G. Hence the correct statement which will be printed will be G comma G. Okay. So this is the end of the all the 10 questions. Okay. If you have any doubt in any of the question, please do ask me. You can unmute yourself. Okay, or use the chat box. Rest, the session is over from my side. Okay, do join the session next week, same time, same link. Okay, okay, 3 more sessions I'll take, week 11, week 12, and a summary session. Okay, after that you will have to appear for the examination. Okay, this is the thing. Still time is there. Keep on revising. I have given the link also of the entire PDFs as well as the recorded YouTube videos. Okay, so go through them, revise properly, go through the entire week's content, which is released in the form of recorded lectures. Okay, yes, this is the thing. The session is over from my side. I'll be still available here for few more minutes. Okay, yes, yes, you can leave. Sir, I can live now. Yes, you can live. I think you want to ask, can I leave now? Yes, you can leave. Okay. If you are having any doubts, then please ask me. Okay. I'll be available here for a few more minutes. Yeah, Steven is asking me about the first question. I'll explain you. No problem. Session is over from my side. If you want to leave, you can leave. Okay. Or if you have any doubt, you can just ask me. Okay. Steven wants to ask the first question. Good. The bisection method is used to yes, Rajesh, thank you all for joining the session. Okay, do join the session next week, same time, same link. Okay, thank you, Rajesh, thank you, Sayan. Okay, yes. The bisection method is used to find, this was the question. Okay, derivative of a function at a given point, numerical integration of a function within a range, or the root of the function, or none of the above. See here, bisection method is used to find the root of the function. Okay, this is the thing. Bisection method, it is a numerical technique which is used to find the root of the function. I already explained you. Okay, within a closed interval a to b. Okay, where the function changes the sign. I explained you with the help of this particular graph. Okay, a and b suppose are 2 points on the x-axis. So bisection method says us that if f of a into f of b is less than 0, then there must exist a root between the closed interval a and b. This is the statement. Okay, so this is the thing. See here, if f of a is positive or f of b is negative, or vice versa, f of a is negative or f of b is positive, then f of a into f of b will be negative. okay, less than 0, then the function curve has to cut at least once between the closed interval a and b. This is the statement. Then how you will evaluate this particular route, this is explained here. How the bisection method works: choose an interval, closed interval a and b, such that f of a and into f of b is less than 0. This will be provided in the question. Okay. Or if it is not provided to you and it is a subjective type of question, just go for 0, 1, 2, 3 and -1, -2, -3. This I explained you. Okay. Then you have to compute the midpoint, which is c equal to a plus b divided by 2. Now you have to update the interval, closed interval a and b, based on the fact that either f of a into f of c is less than 0 or f of c into f of b is less than 0. In whichever direction it is less than 0, you have to update your direction of search in that particular direction only. Okay. If suppose f of c into f of b is less than 0, then update a comma b as c comma b. If f of a into f of c is less than 0, then update a comma b as a comma c. Again, proceed towards this particular manner that calculate the new midpoint, which would be c dash as c plus b divided by 2, or c dash equal to a plus c divided by 2. Okay. In that similar form and manner, try to update the values of a and c, okay, a and b, and then calculate the midpoint. One particular example I have just solved. Okay. Suppose f of x is x cube minus 4x minus 9. Choose an interval a comma b. I have here used the values f of 2 and f of 3. So f of 2 I am getting negative, f of 3 I am getting positive. So there must exist a root between a and b using the value, using the statement of the bisection method. Okay. F of 2 is negative 9 minus 9, f of 3 is positive, so there must exist a root between 2 and 3. Now applying the bisection method, calculating c, which is the midpoint, 2 plus 3 divided by 2, which is 2.5. Now evaluating f of c, which is f of 2.5, which is 2.5 cube minus 4 into 2.5 minus 9, which will be negative. Now in which direction I have to proceed, that I have to just find out using my logic. Okay. F of 2.5 is negative, f of 2 is negative, f of 3 is positive. So I'll switch on to the opposite symbols. Okay. So f of 2 is positive, f of 2.5 is negative. So between negative and positive, there must exist a root, because f of x should cut at least once between those two values. So f of 2.5 is negative, replacing a with 2.5. Now we will search between 2.5 and 3. Always go for the opposite symbols. Okay. So c dash, in next iteration I have calculated as 2.5 plus 3 divided by 2, that is 2.75. F of 2.75 I am getting as positive, and f of 3 was positive, f of 2.5 is negative. So I'll resume my search between 2.5 and 2.75. So now again I'll calculate, which is 2.5 plus 2.75 divided by 2, which is 2.625. So close to this will be some root. So I'll say within the scope of errors, the root is coming approximately as 2.7. So this particular thing I have implemented in the code also. Here I have provided the code, explained the code, and after the 10 iteration, I am getting the value close to 2.7. Okay, this is the thing. Is it clear to Steven? Or is still any confusion is there? Feel free to ask. Okay. Clear, Steven? Sir, how 2.5 is negative? Sir, how 2.5 is negative? F of 2.5, if you will calculate, it is not coming negative. Try to calculate. I'll also calculate with you. 2.5 cube minus 4 into 2.5 minus It is coming exactly minus 3.375. It is negative. I can show in front of the camera. I have calculated it. See here, minus 3.375. It is negative. Go through the PDF once. I am still unable to find out in which step you are having any confusion. Okay. Got the answer, sir. Yeah, you will get it. Yes, sir. You understood, right? Steven, any confusion is there, then please ask me or tell me that if it is clear. Still, if any step, any confusion is there, go through the PDF. Try to calculate everything with your own hand. Okay. Use the calculator. Then you will be able to get it. Okay. Okay. Clear. No problem. Sir, can you please explain questions 2, 3, 4 once again because we joined the late? For this particular purpose only, I'll provide you the entire session's recording. Go through it any number of times, whichever you like. Okay, Rolly, I understand that you must be busy. Okay, so no problem is there. You go through the recording. Okay, available for you. Still, if any doubt is there, you mail me or either you can ask in the next session. Okay, that is the thing. Okay, thank you. Thank you, Steven. Thank you, Rolly, and whomsoever have joined. Okay, session is over from my side. If you are having any doubt, ask me. Otherwise, I'll end the session here for you guys. Okay. Okay. Thank you. Thank you, Rishi. Thank you, everyone. Okay. Thank you for joining the session. I'll leave the session here itself. Do join the session next week, same time, same link. Okay. Thank you all.